Okay, for problem 9 through 14, we need to multiply or divide and then write the product or quotient as one power in exponent form. So we don't need to multiply all the way out or divide all the way, we just need to write it as a single power. So we just need to remember the rules for multiplying and dividing with exponents. When you multiply with exponents and you have the same base number, you can just add the exponent. So this is the same as 2 to the 7 plus 10, which is 2 to the 17th power. Number 10, the only tricky thing about number 10 is you need to realize that x is the same as x to the first power. So this equals x to the 1 plus 8, which is x to the 9th. Number 11, we have a positive exponent and a negative exponent, but our base number is the same. We're just going to treat it the same way. It's 8 to the 4 plus negative 1. And adding a negative 1 is the same as subtracting 1. So this equals 8 to the third power. Number 12. Now when we're dividing, we have the same base number, we just subtract the exponents. So this equals 10 to the 9 minus 4, which is 10 to the 5th power. This problem 13 should have parentheses around this negative 12. It's a subtle difference, but it's actually important. So our base number is negative 12. And again, we're going to subtract, so negative 12 to the 8 minus 2, negative 12 to the 6th power. In 14, we have z as our base number, so the base number to the 5 minus, now we have a negative 2 down here, so 5 minus negative 2. And then off to the side, we can just use KFC, keep flip change, to do this integer subtraction problem. Keep the first integer the same, flip subtraction to addition, change the sign of the second integer, so that's 5 plus 2, so this is z to the 7th power. The rule for taking a base number with an exponent to a power of a power is to multiply the powers. So this is 11 to the 2 times 8, or 11 to the 16th. Here we have 5 to the negative 4 times 0. Anything times 0 is 0, so this is 5 to the 0 power, which is just equal to 1. And here we have n to the 3 times 5, n to the 15th power. Number 18 and 19, we need to write each number in standard notation. First thing we need to do is look at the sign of our exponent. This is positive 6, so this will be a big number. And so I know I need to move this decimal to the right 6 places. 1, 2, 3, 4, 5, 6. I'm going to make it big so I remember I moved it there, and then put some zeros in these empty spaces. So we get 1, 2, 2, 5, 0, 0, 0. Put in my commas, and I get 1,225,000. Now in number 19, we have a negative exponent, so that tells me this is a small number. So that when I move my decimal, I'm going to move it to the left this time. 1, 2, 3 spaces. I'm going to put zeros in those empty spaces, so this is 0.0094, or 94 10,000ths. And I'm going to put a leading zero. There's just a good habit to be in. Doesn't change the value. Okay. On 20 and 21, we need to write each number in scientific notation. Now, looking at this number, this is a small number relative to 1. Small number. So I know I'm going to have a negative exponent. I just need to remember that at the end. So I'm going to move this decimal 1, 2, 3, 4, 5, 6 places. That gives me 1.2. I need a number between 1 and 10. And then it will be times 10 to the negative, how many jumps was that? 2, 3, 4, 5, 6. 10 to the negative 6 power. 21 is a large number, so I know I'm going to have a positive exponent. And the decimal's not in sight, it's on the right. I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 to give me 2.25 times 10 to the positive 9th power. Okay, I'll pick up the review with problem 22 on the next video.